everyone. Welcome to Subnetting a Little Bit. We will once again go through the process of determining the subnet address map corresponding to a given IPv4 address. The previous video presented example 1. This segment brings you examples 2 through 6. First, let us quickly review the three-step process. Step 1 is to identify the native class of the address. Note the range of values in octet 1 and how they map to the specified class. In addition, note the corresponding native address map, where classful octets are represented using an uppercase N. Step 2 is to borrow host bits. When we borrow host bits, they become subnet bits. And as we've mentioned before, subnet bits are network bits. We need to borrow enough bits, so the total number of network bits equals the prefix length. Step 3 is to add enough host bits, so the total number of bits equals 32. Let's look at example 2. Given the address 10.21.31.9/21, we will determine the subnet address map. Step 1 is to identify the native address class. Since the first octet is 10, the native class of this address is Class A. Since Class A addresses have one classful octet, the first octet, we will start with one uppercase N. In Step 2, we borrow enough host bits to convert them to subnet bits, so the total number of network bits equals the prefix length. Recall the prefix length tells us the total number of network bits. The prefix length is 21, so we need to borrow 13 host bits. Add 8 subnet bits in octet 2. And add 5 subnet bits in octet 3. We now have a total of 21 network bits. Step 3 is to add enough host bits to account for 32 bits. We need to add a total of 11 host bits. Add 3 host bits in octet 3. And use one uppercase H to represent 8 host bits in octet 4. One classful octet, or 8 bits, plus 13 subnet bits, plus 11 host bits, add up to 32 bits. And there we have it. This is the subnet address map for the given address. Example 3. Determine the subnet address map for 172.16.88.3/20. Since the first octet is 172, the native class of this address is Class B. Since Class B addresses have two classful octets, we will start with two uppercase N's. In Step 2, since the prefix length is 20, we borrow 4 bits. This gives us a total of 20 network bits. In Step 3, we add 12 host bits to account for a total of 32 bits. This is the subnet address map for the given address. Example 4. Determine the subnet address map for 172.16.11.8/24. Since the first octet is 172, the native class of this address is Class B. Since Class B addresses have two classful octets, we will start with 2 uppercase N's. In Step 2, since the prefix length is 24, we borrow 8 bits. This gives us a total of 24 network bits. Keep in mind the /24 does not change the native class of the address to a Class C. In Step 3, we add 8 host bits to account for a total of 32 bits. This is the subnet address map for the given address. Example 5. Determine the subnet address map for 192.168.0.0/25. Since the first octet is 192, the native class of this address is Class C. Since Class C addresses have 3 classful octets, we will start with 3 uppercase N's. In step 2, since the prefix length is 25, we borrow 1 bit. This gives us a total of 25 network bits. In step 3, we add 7 host bits to account for a total of 32 bits. This is the subnet address map for the given address. Example 6. Determine the subnet address map for 192.168.7.1/29. Since the first octet is 192, the native class of this address is Class C. Since Class C addresses have 3 classful octets, we will start with 3 uppercase N's. In step 2, since the prefix length is 29, we borrow 5 bits. This gives us a total of 29 network bits. In step 3, we add 3 host bits to account for a total of 32 bits. This is the subnet address map for the given address. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.